This is the third video of the summary on Battery Day. It covers the tabless design.
Let's talk about what is in a battery cell. We've got the cap and the can, negative and positive. When you open that cell, you've got a tab connected to those terminals, what we call the jelly roll, which is the wound electrodes on the inside. You can actually see what this looks like as you unwind it. This is over 1 meter long in a typical 2170 cell. We've identified we've got anode, cathode, separator, positive and negative terminal. Watch what happens as we discharge the cell. Got lithium moving from anode to cathode. And then the reverse, when we charge the cell, lithium moving from cathode to anode across the separator. And when we look at what's happened to date, at least in our products, we've moved from the 18650 form factor to the 2170 form factor through great collaboration with our partners.
So a slight note on why is the one called 18650, although not on the slide. The first 2 digits refer to the diameter, and the second 2 digits refer to the length.
This was an evolutionary step going from 1865 to 2170, bringing 50% more energy into the cell. When we look to the ideal cell design, if we were to do it ourselves, so as you can see, we kind of swept the key figures of merit, how much we can reduce the cost and how much vehicle range increases as we change the outer diameter of the cell. We found a sweet spot somewhere around 46 millimeters. But it's not just about a bigger form factor.
Any fool could make a bigger form factor. We're not any fool.
There are problems as you make cells larger. In fact, supercharging and thermals in general become really challenging as you make bigger cells. We came up with this tabless architecture that basically removes the thermal problem from the equation and allows us to go to the absolute lowest cost form factor and the simplest manufacturing process. We basically took the existing foils, laser patterned them, and enabled dozens of connections into the active material through this shingled spiral you can see. 50 millimeter versus 250 millimeter electrical path length, which is how we get all the thermal benefits.
Basically, the distance that electron has to travel is just much less. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs. This is quite hard to do. Nobody's done it before. People that really know cells, this is a massive breakthrough.
For cylindricals to be able to get rid of the tabs dramatically simplifies winding and coating and has an awesome thermal and performance benefit.
When the cell is going through the system, it has to keep stopping where all the tabs are. So you can't do continuous motion production if you have tabs. You have to keep stopping.
We get 5 times the energy with 6 times the power and enable 16% range increase. So just the cell form factor change enables a 14% dollar per kilowatt hour reduction.
If you want more on the Tesla Battery Day, you can continue with the next video, or you can go to the first video that provides an overview of all the videos.